Oh, it is a rainy day out here in Phoenix, Arizona. I know that may not sound like that big of a deal, but it is for us. We get rain so rarely. The last I actually heard on the news, the last time we got rain was 8 months ago, and it was just a drizzle. So whenever it rains here, all the children run out, look at the sky, and they oh water from the sky, and it's amazing, and I love the rain. Rain is a novelty here. But I don't know how I could live in a place where there's a lot of rain because every time I'm looking out the window right now, cloudy skies. I've got my cup of hot cocoa right here. I just want to, I don't know, curl up and talk about NAT. that's that's what we're going to do. We're going to look at network address translation because this is a big function of just about every network that's in existence today. Network address translation allows you to translate your corporate private addresses into the public addresses that work on the internet. At least that's the most common use. So we're going to look at this introductory video at the three major forms of NAT: dynamic NAT, NAT overload, and static NAT. Once we wrap up here, in the next video, we'll talk about how to set them all up. Now, NAT was the topic that we discussed in the icnd2 series, but the primary use that we talked about in there was just overloading an external IP address so multiple internal clients can access the internet. And while that is the most common use of NAT, there's many more things you can use it for. The first one is dynamic NAT. Now, this is a typical picture of using dynamic NAT to translate inside addresses to outside addresses as you access the internet. Now, it sounds just like what I described, but you'll notice that it is a one-to-one translation. As these clients go out from the internal network, they are assigned a public address and it will stay there for as long as that session remains. So if it's a TCP session, there's a certain timeout. Once it ends, that public address goes back into the pool. Now, likewise, with dynamic NAT, you can have it translate the other way. I can go from outside to inside and it can rotate around. Now, you might be thinking, well, where would that be used? I'll tell you the most common place where you see dynamic NAT used is to solve problems with addressing. The problem that I'm mainly talking about is overlapping addresses. Let's say you've got, I'll try and squeeze it in over here. Oh, hang on. Let me do a quick little shindig. Let's say you've got an organization over here that has a router, and organization A acquires organization B over here on the right-hand side. Now, they did not plan in their acquisition system that they would have overlapping addresses. And maybe the A organization decided to use the 10 range, all 10 addresses over here, and the B organization also used 10 addresses. Well, you can't have that because that's going to be duplication. What you can do with dynamic NAT is set up a pool, meaning when organization A accesses organization B, it will look as though they're coming from, we'll say 172.16. something. And when organization B accesses organization A, it will look like they're coming from 172.17. something. That's one form of dynamic NAT that's able to handle dynamic translations for overlapping networks. So while both of these people are using 10 networks, as they access each other, they'll become different addresses, so the devices will think, oh, well, there's no problem. Now, I know this may just seem illogical because if I were in organization B and maybe I pinged an address 10.1.1.5 that also existed in organization A, well, how does the router know which 10.1.1.5 you're talking about since we have overlapping addresses? Well, dynamic NAT, when you're using it in this system, does not work with IP addresses. Let me explain. If you have to have overlapping addresses, which some organizations do for a time, it requires the use of a DNS server. And let's say organization B, we're IT people. We usually think in terms of addresses, but normal people think in terms of names, DNS names. And let's say organization B accesses a server in organization A that is, we'll call it Corp SRV. Okay, and corp SRV is the one that is mapped to that 10.1.1.5 address. Well, as soon as the request goes out for corp SRV, that will be passed to a DNS server through the router. Now, as the DNS server replies, the router realizes, whoa, that's an address over here on the other side, meaning that's something from organization A they're trying to access. So as the DNS reply comes back, the router will rewrite the address to be 172.17. something and dynamically map. How are you even understanding any of this scribble I have on here? It will dynamically map it to something over there in organization A. So the point, let me draw it simpler down here, is you can have DNS here returning responses to names. As it comes through the router will hide what real address it is in organization A and make it 172.17 or 16. something, whatever organization A was using, so that when this PC gets it, it goes, oh, well, I'll send that to my default gateway. Hits the gateway, NAT, dynamic NAT, translates it over to the real address, 10.1.1.5 of the corporate server in organization A. So you can see dynamic NAT, what it does is just do one-to-one address translations. In its simplest form, I can define a pool of address on one side and a pool on the other side, and that pool goes to that pool and vice versa. But you can also use it for some pretty complex stuff like overlapping addresses, and that is the most common use of dynamic NAT. Now, with that being said, dynamic NAT is the least common form used. The most common form of NAT that's used is called NAT overload, and this is where multiple devices share a single address. Now, this is the form of NAT that allowed us to overcome the IP address shortage on the internet by using that sharing system. Here's the way it works. We will have a router that's connected to the internet, and we'll say our corporate network behind here is using 192.168.1 addresses. So we'll say 192.168.1.0/24 exists on this network. Now, as these clients, we'll say we've got 50 and 51, as these clients go out and access the internet, they will share the same public address, and the response will come back to that public address and forward it to these internal clients. Now, this is possible because NAT overload uses port numbers. That's why you see my little note on the bottom. This form of NAT is commonly called PAT, or port address translation. Now, the rumor goes that Microsoft actually came up with that term, but NAT overload is the technically accurate term to describe this. So the way it works is when you open a web browser or I'll say any network application on your PC, we'll just say a web browser, and go to www.cisco.com, the operating system dynamically generates a source port number. We'll say 1536 in this case. Now that source port number is when traffic comes back to that client, it will be sent to that port number so it knows to put it in the right Internet Explorer window. I mean, think about this. Look at your computer right now. You probably have this video open along with many other applications. For example, if you're using Windows Vista, in my opinion, the ultimate waste of time operating system, and I say that not as a slam against Vista, but there's so many gadgets in there that just waste time. And you look at your little gadget bar on the right-hand side, and it's got news headlines that are constantly being streamed in, stock quotes, you've got pictures from the internet, all kinds of stuff that's just constantly coming in. Well, Vista, or whatever operating system you're using, has to have a way to separate all that. So it knows, oh, this data coming in on my network card goes to the stock quote portion. This one goes to the web browser window. This one is streaming radio that you're listening to on the internet. Hopefully not while I'm talking. But well, take an example. If you're using a streaming subscription to CBT Nuggets, right now my voice, the words that are coming out of my mouth, are streaming to you into a specific port number on your PC, and that's how it knows what application to send it to, which is playing it out to speakers. Wow, that's deep. So anyway, you open a web browser, and that operating system generates just port number 1536. It could be any port number that's out of the what's considered the well-known port number range. It's going to go to the destination of www.cisco.com on destination port 80. And that's how the Cisco web server knows you're needing to be sent to the web server application. You're not sending email or anything like that. You're looking for a web page. Well, as it goes through the router, as this arrow in the middle happens, the NAT overload process sees that request and says, okay, you came in on 192.168.1.51.1536, so I will send you out on 200.1.1.1 1536 as the source port number. And that's when Cisco replies back. It will be replying to the destination port 1536 and that public IP address. And when your router gets it, it looks at this table. This is known as a NAT translation table. We'll see it when we look at the configuration. And it looks at this table and goes, oh, 1536, right. That's mapped over here to 192.168.1.51, and poof, you get the web page back. Now that could be happening at exactly the same time as this PC. Let's just say, for sake of argument, that this PC at exactly the same time, the exact, we'll say, second, opened a web browser window and its operating system generated 6751. And that at the same time, you know, Cisco's a popular place to go. They went to cisco.com as well at exactly the same time. Well, that's okay because they both have different source port numbers. So even though two identical requests saying Cisco send me your homepage is coming into the Cisco web server at the same time, it sees them as different because they're coming from different source port numbers. And when it sends information back, the router has no problem handling that because it says, oh, well, you're coming to one port number and you're going to another. So I have in my table what host to send you to. Okay. Now let's talk about an exception. You might know that there are 0 through 65,535 different port numbers that are available for TCP and UDP. Now, as applications are running on a busy network, I mean, you might have a computer that has 50 different network applications open at a time, using up 50 different port numbers. Now, you might think as you start pondering things that could happen, what if two devices happen to generate the same source port number at the same time? What then? I mean, how would it handle that when both of those requests came to the router and they were both using, we'll say, source port 6751? The router's prepared for that because that's actually a very common circumstance, because with a busy network and lots of applications, you can get into thousands of port numbers in use at a time. So the chance is multiple computers will use the same one. The router has no problem handling that. Whichever one gets there first, and there will be a first, you know, because the router can only receive one packet at a time, so one will be 1 millisecond behind the other. Whichever one gets there first will get the 6751 and go out as that. Now, once the other one, we'll say 192.168.1.49 comes in with a source of 6751, as that comes in, the router looks and goes, oh, sorry, man, 6751 is in use. I'll just give you the next free port. So it will map 192.168.1.49:6751 to 200.1.1.1, we'll say 6752. Seems too simple, right? But that's all it does. It just takes the next available port number, and now when the communication comes back to 6752, it looks and says, oh, well, I'll translate that port. Now you see why we call it PAT, port address translation. I'll translate that port back to the original that was sent from the client, 6751. Finally, the last form of NAT is known as static NAT. This form is typically used for hosting servers inside of your network. For example, we have private addresses here, 192.168.50 and 51 and so on. Those private addresses, since they are private, are not accessible from the internet. That's the whole definition of private, is that it is unroutable by internet routers. So we have to use static NAT to map public IP addresses here to private ones. So when somebody wants to access, maybe we have a internal web server, maybe that's this guy running at our company, we can forward that request into the internal web server and allow people to access it. That's known as a static NAT mapping. So here's the idea. Static NAT is usually combined with NAT overload. NAT overload to provide outbound access so normal people can just surf the net and whatever else they need internet access for. And static NAT for the internal. So what I did was show you the NAT table right here, and you can see this top IP address is still doing some form of NAT overload. You can see source port number is going through and being translated. And the bottom one has a little static entry here saying I have statically mapped 192.168.1.51 to 200.1.1.2. Now, the static NAT translations are usually done two ways. I should say always done two ways. Meaning if I statically NAT 192.168.51 to this public address, every time that server goes out and accesses the internet will see it as this public address. It doesn't get thrown in the NAT overload pool like the rest of these devices out here. And anytime someone on the internet accesses that public address, 201.1.2, it will be forwarded down here to this PC. It's two ways, inbound and outbound. Now keep in mind, whenever we do static NAT, or I should say any form of NAT, we do not have to have those IP addresses assigned to this interface of the router. It seems kind of strange, but this interface, we'll call it, we'll just say it's fast Ethernet 0, might be assigned the address 200.1.1.1. Now I can say I might want to use that address for NAT overload, and so everybody pretends they are the router as they go out. But 200.1.1.2 is not assigned anywhere. It's not an address on this interface right here. We haven't assigned it to a loopback interface or some mystery interface. It's just part of the NAT process. So when somebody accesses 201.1.2, our ISP knows to route that packet to our router, who whenever they see that looks at it and says, oh, I have a NAT mapping for you. You may not be assigned to my interface, but I have a NAT mapping saying that you should become 1.51. Now, static NAT, as I'll show you as we get into the configuration, can get far more granular than doing a full one-to-one IP address translation. Meaning right here, I said that I had a web server at 192.168.151, and I mapped this full address to that PC. But maybe, let's expand our diagram here, maybe in my company, I also happen to have an email server, which is 192.168.1.52, that I would like to allow access to as well, so I can receive emails from the outside world. Well, unfortunately, the company that I'm with, my ISP, only gave me two public addresses. Now what do I do? Well, static NAT can be combined with port numbers. So what I can do is I can say 200.1.1.2 on TCP port 80 will forward packets into the web server on port 80. But if I receive a request on 200.1.1.2 colon TCP port 25, I will forward that to 192.168.1.52 on TCP port 25. So we can actually split a public address among multiple internal servers. And you can actually chop this thing up with as many servers as you'd like, as long as you have port numbers. Now, for example, if I had another web server inside of here, maybe I had two web servers, I mean, port 80 is already used up. So I can't somehow magically translate some second port 80 into that because we've used that port on that public address. But this feature is really cool because it lets you use every public address to the max. Meaning, instead of assigning a full IP address to a web server when it only needs port 80, we can chop it up into as many servers as we want as long as we have unique port numbers. And those are the three forms of NAT that we will be configuring in the upcoming video on configuring NAT. That will be also one big difference between icnd1 and icnd2. Back in icnd1, we used the SDM, the Security Device Manager, the graphic interface to set up NAT. In this, the CCNA or icnd2, we will be using the command line, which is far more powerful than what the graphic interface can do. So we saw dynamic NAT. And what dynamic NAT is used for is to convert one pool of addresses to another. So I can say all of these private addresses translate over to these public addresses, or I can use that for overlapping addresses so I can overcome that issue in an organization. We saw NAT overload, which is allowing you to overload one public address for many internal private addresses. And finally, we saw static NAT, which is used to allow you to host internal servers. I hope this has been informative for you, and I'd like to thank you for viewing.